choosing a model by graphing. So for problem number 1, you have to graph each set of points and then determine which model is most appropriate for each of this set. So you have these points for letter A, you have 0, 0, 1, 1, negative 1, negative 0, 5, 0 0.5, and 2, 3. So you have 4 ordered pairs here, and then plot each of these ordered pair on this grid of lines. So you may decide of your own scaling if you want 1 unit per square for the x-axis and different intervals for your y-axis. It depends on you. But then, since you only have these numbers from 0 to 2 for the x-axis, so you can just consider 1 unit for each of this small square here. And then for your y-axis, you have 0, 1, negative 0 0.5, and 3. So you can have the same interval as that of your x-axis. And then just plot these points. So you have 4 points here because you have 4 different ordered pairs. Alright, so this is 0, 0, which is the point of origin. And you have 1 and 1. And then you have 2, 3, which is your 4th ordered pair, and then you have negative 1, so it's on the left of your x-axis, and then negative 0 0.5, so it's below the y-axis, and then that's just half of that. So yeah, so this is the point negative 1 and negative 0 0.5. Let me just make clear this one. Okay. And then after plotting these points, you have to connect these points to make a graph. So the graph looks like this. Alright, now, so which model is most appropriate for this kind of graph? So which two models either continually increase or continually decrease from left to right among all the different models of functions you already knew, like the linear, quadratic, and exponential? So which two models either continually increase or continually decrease from left to right? So the answer to that question is linear and exponential models. Okay, so either it continually increased from lower left to upper right, or it continually decreased from upper left to lower right. So this one is continually increasing from lower left to upper right. Okay, so either this is linear or exponential, but clearly this can't be linear because the rate of change is not constant between the points. So from the lowest point to the point of origin, you see that the rate of change is 0 0.5, and then from the origin to the next point, it's 1 unit more, and from this point to the highest point, it's 2 units up. So the change of rate is not constant. Therefore, this is not a linear function. This can't be modeled linearly. Hence, you are left with one choice, okay, which is the exponential model. So this can be modeled exponentially. Okay. Why not quadratically? Because as the value of your x increases, your values of y also increases. Okay, so this can be modeled by a quadratic function. So for letter A, the most appropriate model to be used here is exponential. Alright, let's proceed to letter B. Now, for letter B, you also have 4 points here. You have negative 2, 11, negative 1 and 5, 0, 3, and 1 and 5. Okay, so the highest value for your y here is 11. That's why I drew the coordinate plane this way. Okay, and you don't need negative of y, so I drew it this way. And then the intervals for your x coordinates are between negative 2 and 1. So there you have it. So the same thing, the scaling is the same for x and y. Okay? 1 unit for x and 1 unit for y for every small box here. And then just plot all these points and then connect the dots. So as you can see, you have a parabolic shape here, a parabolic shape. So clearly, this is most appropriate. This is the most appropriate model for this kind of graph is quadratic. Okay. So the points here are in order from least to greatest based on the x-coordinate. As you see, you have -2, -1, 0, and 1. So how can you determine the correct model? By visually inspecting these, the y-coordinates. The y-coordinates are 11, 5, 3, and 5. Okay, so notice that the y-coordinates decreases and then increases. So you have 11 and then 5 and then 3 and then 5 again. You have 11, 5 and then 3 and then 5 again. So it's unlike linear and exponential models, the values of your y continually increases or continually decreases. But for quadratic functions, the value for your y decreases sometimes and sometimes it increases. It decreases and eventually it increases. Okay, so that's the explanation for this kind of graph. That's why it's a quadratic. It can be best modeled by a quadratic function. Also, clearly you have a parabolic graph here, so this is definitely a quadratic. Okay, so your turn now. Do number 1 and 2.